In this section, we're going to start exploring these things called antiderivatives. And so for the large majority of this course, we've been interested in taking the derivative and finding the slope at a specific point, and then some of the applications such as maximums, minimums, Newton's method, being able to find concavity, and then utilizing that for L'Hopital's rule. But what if we want to go backwards from a derivative? What does that really mean? And so that's what we're going to be looking at in this section, as well as for the remainder of this course. So let's get some just general sorts of ideas about an antiderivative. Let's say we have a function, f of x, and the antiderivative of f of x is going to be capital F of x. And every time that we take an antiderivative, so to go from here to here, we're also going to have this thing plus c, right? And this is going to be just an additional constant. Right? Now, why do we have that? Well, let's take a look at this. Let's say that for some reason we had the function, and let's have two functions, really basic ones. Let's say 3x squared plus 7, and let's say g of x is going to be equal to 3x squared minus 22. Now let's say we take the derivative of that, f prime of x. Well, we know the derivative is just going to be 6x. And if we take the derivative of g prime, well, that's also going to be 6x. But notice that if I wanted to go backwards to here, the antiderivative of both of those is different. Notice that for one we have a negative 22, and for the other one we have the 7. Now, wouldn't it also be true that if my h of x was equal to 3x squared plus 2 pi plus 7e minus the square root of 2, what happens when I take the derivative of that? Well, that's 6x, because these are all constants. And this is a constant. And this is a constant. And so that means that when we take an antiderivative, we're going to get this general constant. And generally, when we take antiderivatives, the solution is not a specific function, but it's a family of functions. And we'll take a look more about that later in the course. All right, so every time basically we take an antiderivative, we're going to have this constant c that's going to go in there. All right. Now, how do we take antiderivatives? Well, you just go backwards from a derivative. All right, so I have a list of rules here. And so let's say we just have c as a constant. Well, we know that if we take cx and take the derivative of that, that's going to give us c. So what we're saying is if I take the antiderivative of c, that'll be cx plus another constant. I'm just going to call that c. And I call that one capital C because they just don't have any relationship. X to the n, usually what we do is we say for the derivative, that would be x to the n minus 1 times n. But we're looking for the antiderivative. So instead of multiplying and subtracting, we are going to add and divide by n plus 1. So, and then of course we have our constant c. We have this constant times a function, very similar to derivatives. It's constant times the antiderivative of the function, capital F, and then plus the constant c. If we take the sum or difference of two or more functions, that means that we could just take the antiderivative of each of those functions individually and then just have a constant. The antiderivative of sine x, be careful, that one's going to work out to be negative cosine of x. And looks like something happened here. So I'm going to erase this. Probably when I was scrolling this prior. If I have the cosine of x, then the antiderivative of cosine is going to be positive sine of x plus the constant. Right? We know that secant tangent, when we took the derivative of secant, that gave us secant tangent. So if we want to go backwards from secant tangent, that's secant. Very similar, you might remember sec square of x If you took the derivative of tangent of x, that gave you sec squared. If you took the derivative of cotangent, that gave you negative cosecant. So now we just flip the negatives around. And same thing with negative cosecant, that would give you cosecant cotangent. All right, so again, all we're doing is we're just memorizing our derivative rules and we're just using the reverse of them. E to the x is easy. The antiderivative of e to the x is e to the x plus c. You might remember some of these sorts of problems. The 1 over 1 plus x squared, that was the arctangent of x, all right, when we took the derivative. So now we take the antiderivative of 1 over 1 plus x squared, and that'll be arctan x plus c. And similarly, 1 over 1 minus x squared is going to be the arcsine of x. And it looks like that for some reason this got mixed up in here. So I'll just get rid of it. You probably remember that the natural log of x. So if we have the natural log of x, the derivative was 1 over x. So if you have 1 over x, the antiderivative is ln of x. All right, so as you can imagine, this gets a little bit confusing sometimes. Sometimes students start to flip the rules around, right? And that's probably what you're going to have to work on, is just making sure that when you find your antiderivatives, you can check the answer. Right? And so what you want to do is you always want to check your answer, at least in the beginning, by taking the derivative. Right? Really nice and easy to do that. Okay. So in the next video, we're going to take a look at being able to just take the derivatives or the antiderivatives, excuse me, of functions. And then from there, we're going to learn about something called an integral.